A regulation baseball has a radius of about 1.45 inches. So here's a baseball, and it's going to have a radius of 1.45 inches. They tell us that the area of a sphere is A equals pi 4 pi r squared. We want to know how many molecules would cover the surface of the baseball if you think of each molecule as a little flat surface of 11 by 11 angstroms. So here's my little molecule, and it's going to have a surface of 11.0 angstroms by 11.0 angstroms. Angstrom is just another type of unit, and you'll see here that 1 angstrom is the equivalent of 1 times 10 to the negative 10 meters. Okay, so basically what I need to know is the total area of the baseball, and I want to divide that by the area of one molecule, and that would get me the total number of molecules that would fit on that baseball. So you'll notice that we have our radius of the baseball in inches, and we have our units for the molecules in angstroms. So we really need to get these to a unit that's the same. So a good idea would be, since angstroms can be changed to meters, then we can go ahead and change from inch to meters as well. So we'll start by converting the radius of the baseball into meters. So I'll take 1.45 inches, and inches can be converted to centimeters because 1 inch equals 2.54 centimeters. And then centimeters can be converted to meters because 1 meter equals 100 centimeters. 0.03683 meters. That is the radius, the radius of my baseball. Notice that I have not rounded. You don't want to round until the very end unless we end up having an addition and subtraction portion in this calculation, then that would kind of change the rounding rules. But in this case, it appears that we're going to have all multiplication and division. Okay, so now with this radius, I can go ahead and determine the area of my baseball. So that's going to be 4 times pi times the radius squared, 0.017045636, and notice this is going to be in meters squared. Alright, so that is the area of my baseball. Now let's find the area of my molecule. So first we'll go ahead and multiply the 11.0 angstroms times 11.0 angstroms. Notice that's going to be angstroms squared. So now I'll take my angstroms squared, and I just need to convert it because that is the area of the molecule. So I just need to convert this now into meters squared. So we'll take 121 angstroms squared, and angstrom squared to meters squared. So for every 1 angstrom, there is 1 times 10 to the negative 10, and because both of these units are squared, we want to square these values as well. So we're going to have 121 times, put in parentheses, 1 times 10 to the negative 10, close parentheses, squared, and that's going to get us 1.21 times 10 to the negative 18, and that's going to be meters squared. Now that we've completed the calculation, notice that my angstroms cancel. Okay, so to complete this calculation, I need to take the area of the baseball, which is 0.017045636 meters squared, and divide that by the area of one molecule, which is 1.21 times 10 to the negative 18 meters squared. Okay, that gives us 1.408730545 times 10 to the 16. Notice that meters squared cancel, and so I'm really just getting a quantity here. We have originally in our problem 3 sig figs, 3 sig figs, 3 sig figs, so I'll go ahead and round this to be 3 sig figs, so my final answer would be 1.41 times 10 to the 16 molecules, which comes closest to letter C.